Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write the molecular, complete ionic, and net ionic equation for a reaction. In this video I'm going to show you the reaction for copper 2 arsenate and nitric acid. So let's get into this. So here you're given the names of the substances, you're not given the formulas. So guess what? You're going to have to go from the name to the formula, and if that is something you struggle with, I'm going to show you how to do that. But I also have a video in the description section on how to name ionic compounds. So if you need a refresher on how to name ionic compounds or acids, look at the links in the description. So here we have copper 2 arsenate. This is an ionic compound. We know it's ionic compound because we have a metal, and we have arsenate, which is a non-metal, and we have the Roman numeral that indicates we have a transitional element here as well. So this would be an ionic substance. Thing to know about ionic substances and their names is that the name of the substance comes from the name of the ions. If you know the names of the ions, you put that together, and that's the name of your ionic compound. So in this way, we have to go backwards. We have to go from the name to the separated ions. And so knowing that the two parts of the names comes from the two ions, here we have the copper 2 ion and the arsenate ion. So all we need to do now is write the formula and the charges. So we know copper is Cu, and the Roman numeral tells you the charge on the copper. So that's easy. The Roman numeral does not tell you how many copper ions you have in your formula. It just tells you the charge on the copper ion. So every copper ion has a +2 charge. So that's +2 because of the Roman numeral 2. And the next thing is the arsenate ion. So again, this is a polyatomic ion. So you're going to need to know the names of your polyatomic ions. You're going to need to know the formulas and their charges. I'm sure your teacher gave you some sort of handout with a table of the common polyatomic ions on there. You're going to need to memorize those. If you need help memorizing them, I have a couple of videos linked in the description that go over patterns and helping you memorize those polyatomic ions. So arsenate here, that is going to be AsO4 3 minus. So that is the formula in charge of arsenate. So now that we have our two ions, what we need to do now is make the formula. And what we're going to do there is to balance the charge. So here I have 2 plus and 3 minus. So an easy way to do this one is to do the crisscross method. So the crisscross method is where I take the numbers of the charges and I write them as subscripts for the other ion. So this 2 becomes a subscript here. This 3 becomes a subscript there. And now all I do is I write the formula. So I'm going to have Cu3, and then I'm going to have AsO4 2. I'm going to have to put the arsenate into parentheses because I have more than one. So I'm going to put a 2 here. So again, if you have more than one polyatomic ion in your formula, you're going to have to use the parentheses in order to indicate that. And the number of the ion goes outside the parentheses. If you only have one polyatomic ion in your formula, don't use the parentheses. Okay, so now we have our one substance. Now, what about nitric acid? So this is an acid. There's two groups of acid. There's two categories. There's your oxyacids and your binary acids. And so you need to know how to name both, and you need to know how to identify whether you have one or not by the name. A really easy way to identify your binary acid is by the beginning of hydro in the name. So if your name of the acid begins with hydro, that's a dead giveaway that you've got a binary acid. If it doesn't begin with hydro, you don't have a binary acid, you have an oxyacid. So here we don't have hydro as a prefix to the name of your acid, so we don't have a binary acid, we have an oxyacid. And so that means that your acid is coming from or is based on one of the polyatomic ions that has oxygen in it, like your sulfite ions, your phosphate, your phosphide ions, your nitrite ions. And so here the niter, the NITR, indicates that you have a nitrogen based polyatomic ion. The IC here indicates that the polyatomic ion has an ATE ending. So this is based on your nitrate polyatomic ion. So all we're going to do is we're going to write our nitrate ion. And so all you do is you add a hydrogen to that to balance the charge. Since we have a -1 charge and hydrogen is a plus, has a +1 charge on it. So then that's going to be H. So all we do is write an H there and we are good. So that is our formula for nitric acid, HNO3. So that's going to be plus HNO3. So let me write this better. So this is going to be HNO3 like so. Okay, so now we have our two reactants. Now all we need is our products. So how do you get the products from your reactants? Well, you had noticed we have an ionic substance here, and here we have an acid. Nitric acid is one of the strong acids. This will break apart in completely into ions. So this we can treat like an ionic substance. Acids are not ionic compounds; they are molecular compounds, but they will ionize in water. So this strong acid will ionize completely in water. And so we can treat both of these like ionic substances. And in that case, we can treat this as a double displacement reaction. So it is a double displacement reaction. And to find the products of a double displacement reaction, all you do is you put the inside ions together and you put the outside ions together. So when you're putting the ions together, remember you need to balance the charge. So here we have copper. Copper has a 2+ charge, and we have nitrate that has a -1 charge. So we're going to need two nitrates to balance the charge on the copper. So we're going to have Cu, and since we have two nitrates, we're going to have parentheses, so NO3 2. So that's one product. And now we're going to put the hydrogen with the arsenate. Arsenate, we said, had a -3 charge. So we're going to need 3 hydrogens to balance the charge on your arsenate. So that's going to be H3ASO4. Okay, there we go. So there's our products. So now all we need to do is balance the equation and figure out what the states of matter are. So let's balance this equation. So I have, excuse me, I have 3 coppers here. I only have 1 copper there, so I'm going to have to put a 3 here. So now the coppers are balanced. I have 2 arsenate ions here, but I only have 1 here. So I'm gonna have to put a 2 here. Okay, so now that's balanced. Okay, so let's go here to the hydrogen. I only have 1 hydrogen here, but now you'll notice I have 6 hydrogens here. So I'm gonna have to put a 6 here. And now I have 6 NO3s, and here I have 3 times 2 gives me 6 NO3s. So that's balanced. It looks like everything is balanced now. So now we have our balanced equation. And so the last thing is to figure out the states of matter. So arsenates, when you're figuring out your states of matter for your ionic substances, it's always good to have some sort of solubility rule or solubility chart. Your teacher probably gave you one. I'm using solubility rules. So here I'm looking for arsenate. and my solubility rules don't have arsenate, but we do have copper. Let's see if there's a copper in here. Okay, so the arsenate, arsenates are insoluble in water except for some exceptions. So copper is not an exception, so that's going to be, we're going to expect that to be a solid. HNO3, that is a strong acid. So the thing about strong acids is that they will ionize completely in water. So this will fall apart, but so this is going to be aqueous. This is going to be soluble in water. So even if this was a weak acid, we will still write aqueous because even weak acids, even though they don't fall apart, it still will dissolve in water. So that's going to be aqueous. Nitrates, according to the solubility rules, all nitrates are soluble. There really are no exceptions. So that's going to be aqueous. And we here have arsenic acid. We know it's an acid because it begins with H3. This is going to be a weak acid because it's not one of the 6 strong acids. So that's going to stay together, but that's going to be aqueous as well. Okay, so now that we have our balanced molecular equation, now we can go to our ionic equations, and the ionic equations are going to be the complete and the net ionic equation. For the complete ionic equation, all we're going to do is we're going to separate out any ionic substance that is aqueous, and any strong acids are going to be separated out. The only things that are not going to be separated are going to be anything that's a solid, liquid, or gas, or any weak acids or weak bases. Those are going to stay together. So here we have a solids, that's going to stay together. So we have Cu3 ASO4 2 solid. And so here we have a strong acid, so that's going to be separated. Since we have 6 HNO3s, that means we're going to end up with 6 hydrogen H plus, 6 H plus, and 6 NO3 minus. So we're going to do 6 H plus aqueous. And you'll notice that when I'm writing the ions separately, I write the charge. When we have the ions in a formula, you don't write the charge. Here, we don't have an ionic substance. It's a molecular substance, so there's no charges really here in the formula. But they are separated. If this was a molecule, if this was not aqueous, if this was like liquid, then that would definitely not be an ionic substance. But since it's aqueous, these are not together in a molecule, so they would be ions in this case. So now we have the NO3, so we're going to add plus 6 NO3 minus aqueous. So now we're done with our reactants, and so we go to our products. This is aqueous, so we have 3 coppers. So we're going to write 3 Cu2 plus aqueous. And we have 3 times 2 equals 6 nitrates. So that's going to be plus 6 nitrates here, aqueous. And then this would be a weak acid. That's going to stay together. So we're not going to break that apart. So that's going to be 2H3ASO4 aqueous. And so now we have our complete ionic equation. And so that's CIE. So for the net ionic equation, NIE, we're going to get rid of the spectator ions. So we need to find the spectator ions, and we do that in a couple of ways. First, you can look at the products and see what over here is part of that product, what is involved in making that product. And so you would keep those, and anything that's not involved in making the product, you would eliminate. Another way, and probably a better way, is to look at what changes on both sides of your equation. So when you look here, you see your copper and your arsenate ions are in solid form. If you look over here, the copper is in now aqueous, so the copper is changing. So we're going to keep the copper. And then your arsenate becomes part of your H3ASO4. That changes. So we're going to keep both of these. Your 6H plus ions, that also gets involved in here. So that changes. We don't have 6H plus ions over here anymore. So that changes. So we'll keep that. And here we have 6NO3 aqueous. And here we have 6NO3 aqueous. So there is no change here. So that would be a polyatomic ion. So we can get rid of that. So 6NO3 minuses are gotten rid of. And that's it. So then for the net ionic equation, all we do is write what's left over. So here we have Cu3 ASO4 2 solid plus 6H plus aqueous. And then that's going to go to the product. So we're going to write 3Cu2 plus aqueous plus 2H3ASO4 aqueous. And so this would be your balanced net ionic equation. So I hope this was helpful. If you enjoyed this video, if you learned something from this video, if I helped you out in any way, please like the video, share it with your friends, hit the subscription button, hit that notification so you can be notified by other videos that I put out. And also put a comment in the comment section. Let me know what you think and if you have any questions. Thanks for joining me and have a great day.